So allow me to say these steps one more time, because for some reason I stopped the video here, but I didn't start. I forgot to start it again. So y prime equals 9 x to the 8th, and the initial condition is when x is 0, y is negative 9. So we replaced y prime by dy over dx equals 9x to the 8th, and then we multiply both sides by dx, and we already separated the variables, so now we can integrate. Y prime is 1, this prime is 9x to the 8th, plus a constant c. We simplify and we get this as the most general antiderivative, and now we have to plug in the point when x is 0, y is negative 9, so c is negative 9. So this is a unique solution. Good. 13. We're only asked to show that this is a solution to this differential equation. We don't have to solve. They're only asking us to find y prime and y double prime and say yes or no. Is this okay? Let me know, we can go back. We are given a function. You have to be very careful how you plug it in, because this is really not even algebra. It's lower than algebra, right? You just have to be careful how you plug in those numbers. Do I need to show this one? Okay, 15. So we're asked to find the maximum profit. And the profit is a function of two variables. So we have to use the d-test. It's similar to finding the critical numbers, etc., but now we need a point instead of a value. So it's a critical point instead of a critical x value. I don't hear anything, so I will move on.
Can we do this one, please?
Yes, of course. So here, first of all, we have to determine the profit function. So p of x will be the revenue, which is 4x plus 6y, with minus x squared plus 2xy, minus 9y squared, minus 6x, plus 44y, and plus 3. So I distributed a negative sign, or negative 1, to all terms in the cost function. Now I have to rearrange it and simplify it as much as I can. So I have a negative x squared. I have a negative 9y squared. So these are done. I have a positive 2xy. I have a 4x with a negative 6x, which is negative 2x. So now these are done. And I have 6y plus 44y, which is 50y. And I have plus 3. And everything is accounted for. Now I have to find px, and I have to find py. I have to find psxx, pxy, pyy, and then pyx. All 6. First order partial derivatives and second order partial derivatives. So I differentiate this with respect to x. I see here negative 2x, no x. I see here 2xy prime is positive 2y. I see x here, negative 2. I see no x and no x. Is this okay? Py. I see negative 18y. I see positive 2x. No y, and plus 50. Hi, George, you did well. I'm happy.
Good afternoon, thank you. I just finished. I'm literally still on the way home, actually.
Okay, thank you. Okay, pxx, -2. Px with respect to y, 2. Pyy, -18. Pyx has to be the same. Now we have to create the system and set these two equal to 0 because we have to create a point. Good. So -2x plus 2y minus 2 equals 0, and -18y plus 2x plus 50 equals 0. I wrote the raw system, but the raw system is not correct. I wrote it, but now I have to rearrange the whole thing. Terms with x have to be one below the other. Terms with y have to be one below the other. The free terms have to be on the other side of the equal symbol, and the equal symbol under the equal symbol. So, and I can also divide both by +2. So I have -x plus y. -2 is moved to the other side, becomes +2. I divide by 2 and I get 1. Here, I also divide by 2. So 2x divided by 2 is x. -18y divided by 2 is -9y. I have to move 50 to the other side. It becomes -50, and I divide by 2 and I get -25. So I rearranged both equations in the correct order, and I also simplified them as much as I could. Now this at this point is an easy situation because I can use the elimination method. These go away. -9y equals -24. I love it. Y equals 3. When I go back and replace y in here by 3, I have to find x. So -x plus 3 equals 1 means -x equals -2 or x equals 2. So I have 2, 3 is the critical point. All I need to determine now is the D test, or the D number if you want to call it D. fxx at 2, 3 multiplied by fyy at 2, 3 minus the fxy at 2, 3 squared. And you know that this can be positive, it can be negative, or it can be 0. We are only interested in when it's positive. So now, dxx, I'm sorry, I put f, but you know I mean p. Sorry. Our function is called p. So I cannot even plug in -2, 3 because this is already a number, nothing else. Pyy is -18. I cannot plug it in. I should have, but I cannot. And this is 2. So we have -2 multiplied by -18 and -4. Obviously, this is a positive number. I don't really care what it is because this is 36 minus 4, so it's 32. I only wanted to know if it's positive or not. Because it's positive and because pxx is less than 0, what does 2, 3 give? Two, 3 will give
On the max.
a relative max, indeed. But what is it? I have no clue. I have to find p of 2, 3. So in this function, I have to replace x by 2 and y by 3. So 2 squared, 4 with minus in front. 9 times 9, 81. Plus 2 times x times y. 4 times 3 is 12, plus 12. Minus 2 times 2, minus 4. Plus 50 times 3, 150, and plus 3. Okay, so I'm just going to calculate minus 81 plus 12 minus 4 plus 153. I got 76. We're going over the test, George. So the maximum profit is 76, and they're selling maximum profit by selling 2 at the price of 3. I'm sorry, 2 solar panels of type A and 3 of type B. So here we're asked to use the table and put it in, find a linear regression line, and then evaluate and evaluate the y hat, the predicted value in 2022 and 2024. Do we need help with this one? Okay, and the last one. Is that a yes? This is a differential equation. Is it a yes or a no? Okay. Good. I'd like to go back to test 2. Any questions? Is there anything that you think we should still review from chapters 4, 5, and 6? So I'm reopening everything till the 11th. So you can see everything, so you can play with it, so you can do whatever you want to do. Okay, everything is open again. Again, do we need to work on anything else from chapters 4, 5, and 6? Any questions again about the test? Okay, in that case, I want to go back and review test 2. It's not going to let me review here. Let me go back. Okay, so let's start. Is this a yes? I couldn't hear you.
Sure.
Okay, so for f of x equals natural log of 7 minus 6x. Remember, natural log exists only if the quantity we apply it to is strictly greater than 0, not even equal to 0. So I move 7 to the other side. I have negative 6x greater than negative 7, and I divide by negative 6. But when I divide both sides of an inequality by a negative number, if I multiply or divide, it doesn't matter. I have to flip the inequality symbol. So therefore, the domain of this function is negative infinity to 7/6. So when I go back and I look at the graphing calculator and I plug it in and I clear everything else, very simple to plug it in, natural log of 7 minus 6x. You have to adjust the viewing window though, because the graph exists only between negative infinity and 1 and a little bit. 7/6, it's 1 and 1/6. So I go to the window. That's why I determine the domain first. Okay, the negative 10 is okay. But beyond 1 and a little bit, not really. So I'm going to just put 4. Scale of 1 is fine. Y minimum, I'm going to put negative 10 to positive 10 with a scale of 1 or 2. Okay, so let's see. Because I know the range is only on numbers. And I also know the domain is negative infinity to a little bit over 1. Aha. Of course, we know it doesn't stop here. There is a vertical asymptote. Right? Because that's the domain. Negative infinity to tiny bit beyond 1. And then I look at what they're showing me. Makes no sense? Makes no sense. Ah, makes no sense. So it can only be C. Good. Differentiate. Is that a yes? Is that a no?
Sure, can we do this one?
Of course. So here is f of x equals x to the 9th minus 5e to 2x. So when we differentiate this, we get f prime. We bring down 9, subtract 1 from the power, minus 5 times 2y, because when I differentiate e to a function, is e to that function times the inner function prime. So I put a constant in front already. So the final answer is 9x to the 8th minus 10e to 2x.
How many questions will be on the final?
Not more than 20. Around 20. And you will have an extra credit.
Okay, thank you.
Thank you. Okay, let's look at number 3. Find the derivative with respect to x, of course. But this is a product of two functions, so we have to use the product rule.